Hello, fellow math friends. Let's talk today about classifying two-dimensional figures. Classifying just means we're going to group these figures based on stuff they have in common. So let's try a sample together. Here we'll be grouping things based on angle similarities, comparing acute angles to obtuse angles. Remember that acute are smaller than a right angle, smaller than 90 degrees. Obtuse angles are larger than 90 degrees. So in this first image, the pentagon, it appears that I have all obtuse angles. Those all look larger than a right angle to me. We're going to put that in the obtuse angle section. The trapezoid, the next figure, appears to have two obtuse angles on top and two acute angles on bottom. I'm going to put that in the center section there. The rectangle has all right angles. There's no category for that, so it will stay where it is. The parallelogram appears to have two obtuse and two acute, so that's sum of each. The hexagon appears to have all obtuse. The next figure, the parallelogram, appears to have two obtuse opposite and two acute opposite. And then lastly, this triangle looks like all acute angles to me. So everybody has a home but the rectangle for this example. Now let's look at lines in figures. Remember, parallel lines do not touch and perpendicular lines intersect at a right angle. So that first figure, the pentagon, does appear to have both parallel and perpendicular lines. You'll see the parallel lines here, and then perpendicular lines here, and maybe even here. Our trapezoid, the next figure, appears to have one set of parallel lines. That's just this one and this one. And then the next figure, the rectangle, has both. It has 4 right angles, so those are all perpendicular lines, and then opposite sides are parallel by definition. The parallelogram that is next has 2 sets of parallel sides. I don't see any right angles, so no perpendicular lines, so he just goes in our parallel lines section. The octagon appears to have several pairs of parallel sides, but no right angles and no perpendicular lines. And the next parallelogram, by definition, 2 sets of parallel sides, but no right angles, no perpendicular sides there. And lastly, this triangle has one right angle, which means it does have a pair of perpendicular lines. You see them here. Okay, let's talk about acute, right, and obtuse and how many we have. So first of all, we're offered a right triangle option right here. And a right triangle has exactly one right angle, so it cannot go in the more than one right angle section, but it always has 2 acute angles along with its right angle. So a right triangle does indeed have more than one acute angle. A rhombus. Rhombus is fun because it can have 2 acute and 2 obtuse angles, but it can also be a square, which means it can have 4 right angles. So a rhombus does have either more than one acute, more than one right, and or more than one obtuse. It has many homes. A rectangle has 4 right angles, so by definition it has more than one right angle, but that's the only type of angle it can have. And then a parallelogram can be many different things like a rhombus. It can have more than one acute angle, it can have more than one right angle, and it can have more than one obtuse angle. Okay, one more for fun. Here we have 3 figures, and we're just going to identify some things that we see that they have in common. If we consider the sides, I see sets of parallel sides, several of them here, and a couple of them here. And then in the octagon, here's some, and here's some. So definitely at least 2 pairs of parallel sides for these figures. What about the angles? Do you see anything in common with the angles? Well, these all appear obtuse to me in this first figure. I have 2 obtuse here, but I also have 2 acute. And then it appears I have all obtuse in the octagon. So what I'm seeing is that we have at least 2 obtuse in each figure. Do you see anything else they have in common? How about number of sides? It looks like they all have at least 4 sides. So there's some stuff they have in common. Okay, now it's your turn.